Pincus. I'm the viticulture extension specialist at Oregon State University. I know some of you, I recognize a lot of familiar faces. Oh, wow, so who's come to harvest? I don't know. Okay, that's what struck my, so this module, of course, we did a lot of planning for this well in advance, and so we wanted to talk about water stress management. And of course, this year is maybe not the most stressful in terms of our soil dryness and our precipitation, but it still is a concept that I think is good to start covering, even for here in the Willamette Valley. How many of you are from the Willamette Valley? Okay, so I figure the majority of you would be. Any of you irrigate? Okay, so a number of you irrigate vineyards. And two of the things I wanted to showcase today, I guess three of the things, is some of the basics on water stress and how to detect it, and then talking about two devices that we use for monitoring water stress in particular. Given the relatively short period of time that I have today, I wasn't going to go into every way to look at managing an irrigation program, because obviously you need have both weather station data for ET scheduling. You'd also need soil moisture monitoring, and you need plant water stress monitoring, as well as to have the full suite of the tools to look at. Rather, I decided to focus on the plant water stress monitoring, because I think for a lot of the Willamette Valley, and maybe even part of Oregon and other areas that irrigate, is figuring out when do we actually need to irrigate, and that's when you look mainly at the plants themselves. The soil moisture will tell you good information, but really testing the vine as to what its internal water status is at is really the most important factor. Depending on where you are in the United States and how you irrigate it, you may not need to do it all summer. It might be just, okay, this is when we are starting our irrigation in July, and then we're going to carry it through the rest of the summer. I think for here in the Willamette Valley, the people who have used it mainly for the purpose of trying to figure out, do I need to irrigate at all? You know, if you only have so much irrigation you can put on at a certain time. I know that is what Stoller has done here. We've had a research trial since 07. Actually, 07 to 2015, I collected soil moisture and plant water stress measurements in a block that's just a bit north of here. It's actually within this block here. It was actually a vineyard floor management trial. We were looking at how we might be able to stress out the vines and make them a bit smaller, because as you can see, Stoller is a relatively vigorous site, and much like a lot of the vineyards in the Willamette Valley, the biggest problem is trying to manage that vigor. And they have irrigation, you can see it's in there, but they weren't using it as a constant irrigation throughout a summer. They usually were applying some water in the later part of the season, usually just before veraison or after. And when I came in, we basically did a trial with the vineyard floor management to see, okay, can we pull out more water or nutrients to devigorate these vines? And we also looked at irrigated and non. We actually didn't do the irrigated and non very long, because we very quickly found we really weren't water stressed enough to even put irrigation on. They had done it in practice, and then after a while we couldn't even detect any differences with their irrigation. So they eventually decided, well, we're not going to worry about watering this block, which is well established. It was established in 1998. So they moved their water resources to other blocks that, new plantings that would require more water. So we've got a lot of water stress data from this vineyard, and what we used is this pressure bomb. So right there, I'll walk through that piece of equipment. But first, I want to start out with what water stress symptoms look like, because I'm sure not everybody has invested in the equipment to do plant water stress monitoring, and there's a lot of visual symptoms that can be detected, and oftentimes you want to be using some of those visual symptoms in addition to these pieces of equipment, because as you can imagine, there's error in its use. Or you may want to understand, well, we're only getting to 10 bars, but you see visual symptoms of water stress, and that can be a sampling error, because you can only measure so many leaves with these two pieces of equipment, but you have an entire vineyard to look at. So I'm going to go through some of the symptoms that we often see. One of the first ones, and a lot of these symptoms get tricky because they really are time sensitive. So time sensitive relative to the season especially because as you all know, watching grapevines grow, you've got more tender shoots early season, late season. Right now we start to see lignifying of the shoots, so some of these symptoms are actually a little bit harder to see this time of year. And a lot of these pictures were taken earlier in the summer. So one of the first symptoms we see when you have actively growing shoot tips, you see that the shoot tips will start to droop over and the tendrils will hang. And normally a very well-watered, healthy, turgid vine is going to have tendrils that stick up, and you actually, you move the whole shoot, they're going to move with it. These will be very kind of flagging. And so here's just another picture of what this, and these are from actually what vineyards that were clearly water stressed. You can take a look at those. So another symptom that we often see is after a while, and the tendrils drooping or hanging is something that will happen initially, and if you're under sustained water stress, they will actually stop drooping, and what will eventually happen is you'll have some of these tendrils will start to dry up. And now you'll see a lot of that this time of year, just as the natural progression of the vine going through in the hardening for the winter. But this is from a vineyard where they clearly were having shoot tips actually drying up, tendrils starting to hang, and they eventually become brown, necrotic, and fall off. So very water-stressed vineyards, you may not see any tendrils at all. So they start to drop off. The other thing I want to point out in this picture is the angle of the leaf. So you can see the petiole has now kind of, if you have a healthy leaf, the petiole will be perpendicular to the leaf surface itself, and it'll start to hook. So you can look at those two symptoms there. And this is another example of this is a shoot tip. So much like the tendrils, the shoot tips will then dry up, actually stop growing, dry up, and fall off. So this is like the beginning stages of that stress, and this is after, where we have some of these tendrils have already drooped, and you don't see a shoot tip on there at all. And that also can happen late in the season, so beware of that as well. Your shoot tips will fall off and dry up, even in non-water stress vineyards. So another thing that we noticed, and this was in a stress test that we did on grapevines a number of years ago, and I did this with Paul Schreiner, who many of you know. He has a pot and pot research project where vines are grown in pretty large pots, and then he has to irrigate them every day, and he decided, well, I'm going to do some of these stress tests and not irrigate them for a sustained amount of time, and then we'll look at the response. And some of the first responses were those tendrils hanging, those leaves angling. But one of the things we were kind of surprised at was, and of course this was done at about bunch closure, and we saw that there was wrinkling of the berries. So the vine itself was taking water from the berries. We didn't necessarily think that was going to be happening. We thought that they would sacrifice tendrils and leaves first, and certainly they did that. But within about the same time period, these berries started to shrivel, and you can, I'll pass this around, you can see some of how those berries had done that. And when we reapplied water, the first thing, so the sequence was that the berries kind of shriveled, but the sequence of things refilling, the berries refilled first. And you can see it visually. So, before the shoot tips popped back up and the tendrils were more turgid. So that was a very interesting thing to witness. And of course I think that this happens in commercial vineyards, and especially around that bunch closure time when we're starting to get warmer temperatures in a typical year, and then we oftentimes see burning. And I'm wondering if some of the burning may be related to some of this type of event during a hot day. We've got big vines, lots of water moving through them, and you may get some higher heat and that sun exposure, and now you've got berries that have less water, and when you have less water, you can't manage that heat very well. So that's probably what leads to some of that burning.
Patty, did you see did the shoot tips stop before you saw the berries wrinkle?
Did they stop?
Yeah, the shoot tips stopped growing before you saw the berries
in this situation, it was a matter of just a couple hours that we did the stress test, because they're in a potted system.
Sure.
So it wasn't that they would have stopped growing, or so we didn't do it that long term. But that's a good question. Would they be at that stage? In this case, they had still strongly growing shoot tips and nice tendrils at that same time that they had the berries, and they obviously were at around bunch closure.
Do you think it's just a bit of xylem backflow? Okay.
Probably, yeah. Yeah, so it's interesting. It's something that, to do another test like that would be kind of interesting to follow through.
Did you take any pressure bomb readings?
We did.
Yeah.
So at that same time, we took barometer readings, not with this type of barometer, but with a Lycor barometer, and then with a pressure chamber.
Yeah.
And they did register around 12 bars.
Okay.
Yeah.
Cool.
So it was following what we thought. So we would, as they were getting progressively stressed, we did go through and measure those. So it was aligning with a number that we would assume. And that's always a question we have around here is that, we take a lot of our pressure bomb readings. We get not very stressed. Normally stress is considered around 12 bars. We don't necessarily get to 12 bars. And then a lot of people have asked, well, what if we're in stress before that? Certainly, it is a moving scale, but usually the turn on irrigation stage is at that 12 bars, which is considered moderate stress. So these are the visual symptoms. I know people have mentioned other things that they have used, such as using leaf temperature or the touch test. That certainly is helpful, but it cannot be too terribly diagnostic. But that's something that if you do, you can pair with some of the visual symptoms. The other symptom that you'll eventually see is, this is an example, this is from Southern Oregon, where this is a vineyard, relatively young vineyard, but they just didn't have enough water to get through enough water to these vines. And pretty early in the summer, they were seeing yellow leaves. So that's again something you'll see late season, but if you're seeing that, especially on young vines relatively early in the season, then that's another sign of water stress. So any questions about the visual symptoms? Yes?
If you have the visual symptoms, and for example, the shoots are not really growing anymore and the tendrils are kind of drooping, you can't really give it too much water at that stage to kind of make it shift back to producing leaves versus ripening fruit, right?
So that's a great question. I think what we oftentimes do is say that we want to control the vine, and really when we're talking about water at this stage, you're not going to be able to tell it what to do. It's going to do what it wants to do, and it should, because it's a vine. It knows how to organize itself. So if you see drooping leaves and you provide water, you can't force it to say, okay, only go to the leaves or only go to the fruit. So it's going to go where it needs to go, essentially. What I think a lot of people get concerned about, especially late season adding water, is that they're going to get this extra flush of growth. And if you see water stress, adding more water is not going to cause an extra flush of growth. Nitrogen or fertilization will do that. But adding the water is just maintaining its internal structure. So I think that's one of the biggest problems with especially people who are against late season irrigation in highly irrigated areas or very arid regions, is thinking, well, we have to stress it even through the last phase of grazon. And that's not beneficial to the plant, especially if you're going through ripening. You have to have a good canopy to support sugar development to go into that fruit. Does that answer your question?
Yeah. Thank you.
Any other questions about visual symptoms? So in addition to these visual symptoms, I wanted to just show you two different types of equipment that can measure pressure or that measure water stress. And these are both commercially available. One of them I actually bought only to really test it to see how well it worked and maybe if it would be a cheaper thing that I could use for research, because there's a research grade one of these that I do have as well. So it's the leaf barometer, but mainly what I have used for most of my research, or all of my research looking at plant water stress, has been the pressure chamber, or what many people know as the pressure bomb. So what I have here for you today is kind of a how-to list, and you can find more information online, but I have kind of the key points on the important tips of how to use the equipment, how to take a measurement, how to interpret the data, and then where to purchase them. I do want to say that I do not work for either of these companies, and there are different companies that do make these sorts of equipment, so it's not saying that these are, that I endorse only these products, but you are, just be aware that there are other alternatives out there. These are just the most commonplace, locally available. The leaf barometer that I'm showing here is, it can purchase from a place called Decagon out of Pullman, Washington, and the pressure chamber actually was originally in Corvallis and now is in Albany, Oregon. So you can actually buy all of that locally. So I'm going to pass these around. You take one. And I'll talk about the two different pieces of equipment. And this setup is my setup for research. We don't have ATVs. We're usually using relatively small plots that we're doing this in. So we use a wagon and just a setup. But when you buy a pressure chamber, you have this main unit, which is the chamber, and then you have a gas tank. And what the pressure chamber is doing, it's been around for a long time. I would consider it the gold standard for measuring plant water stress. And it basically is measuring the amount of tension that the water is under within the plant. And it uses only leaves, so at least for grapevines. For different crops, you can use different parts of the plant for this. But basically, you're taking a leaf and you're assessing it, you're putting it in this chamber. There's a chamber here. You're adding inert gas, which is usually compressed nitrogen gas, so N2. And you're basically putting that leaf under pressure and then trying to see how much pressure it takes to push the water out of the petiole. And when the first time you see a bubble is when you stop the chamber and you say, okay, how much pressure, or it reports in tension, but it's pressure in bars, did it take to push that water out? So the less water you have in that leaf or in the plant, it would take more pressure to push it out, right? So it's more of a water deficit. So that's how a lot of the people who've done research on plant water stress for grapevines have found it to be that vines are under a particular level of stress at certain pressures. So right now, the best data and information we have is that under 12 bars of pressure, if it takes that much to get the water out, those vines are considered to be under moderate stress and you would need to start irrigating. So on your sheets, you'll see that I have that in the little box on, I think the second page or the back of the first page, is an interpretation guide for if you're taking leaf measures, what's your decision point. Obviously, if you don't irrigate, then you may want to consider some other method to deal with the plant stress that you have. But it's a pretty easy process. I think how many people have a pressure chamber and are using one? Okay, so I think that certainly if you talk to the Californians, they'll say they like this, especially the people who do irrigation research. They like the pressure chamber. I have to agree, it's easy to work with. It's not terribly expensive. It's easy you don't have a calibration step every day. You do have to do some service on it, at least for research. I send it to the company annually, and we do a lot of readings. And the company always says to me, well, you don't need to calibrate this every year. I'm like, but I'm a researcher. I have to calibrate this every year, and it's $100. It's not terrible. And you really can't break them. The only thing that usually would break on it is this right here, and it actually tells you to be careful with it right on it, and don't move it around or do a lot of changes on it. And you can get really consistent readings very easily. And we'll actually go through and do some of the measurements in the vineyard. So the other thing that's you can use, and this is commercially available, is the leaf barometer. Now these used to be available only to researchers, and it's a very expensive piece of equipment that they only make so many of them and sell them to researchers, so the price tag is just crazy. But then they started making this smaller version for really more for industry to start using, and it only measures stomatal conductance. So this measures how much water is basically in the xylem, and can you push it out of the xylem of the leaf. This is going to be measuring at a much smaller scale. It's actually measuring in this little tiny space here, and I'll walk around and see. So this little tiny hole, it'll be measuring, you clamp it on the leaf surface, and it'll be measuring how much water will be coming out of the stomata on the leaf surface that covers that little hole. So, that's a pretty small part of a normal sized leaf. And so what stomatoconductance, again, stomata are on the basal side of leaves in grapevine, only on the basal side or the underside. That's where your carbon dioxide goes into the leaf and water vapor comes out. And that's that part of the process for photosynthesis. So if a vine is not under water stress, they're going to be open, actively exchanging carbon dioxide and water to go through that photosynthesis process. Once they're under water stress, they get this hormonal signal to start closing, and then they start to reduce the amount of CO2 coming in and water vapor going out. So what this is literally measuring is how much water vapor is coming out of those leaves, and that's what's known as stomatal conductance. Fancy word, but relatively simple thing as to what it's measuring. And when you use this, it's probably much less intimidating because you don't have this big kind of tank-looking thing, nice small sensor you can walk around and use. But there's some things that people need to be aware of. First thing, I know a lot of people want to know price. Price for one of these and one of those is about the same. So about $2,700 for this. Depending on the setup you get for a pressure chamber, there's different models you can get. It's still going to be about the same price, and you can get add-ons, but it's about the same price for both of those. This one does require a calibration step. I actually worked with Amelia and another one of my students to try to calibrate it this morning before, and we finally stopped because it probably, 20 minutes?
At least.
Yeah, 20 minutes we were trying to get it calibrated and it wouldn't calibrate. Part of the reason is with a pyrometer, what it's measuring is very critical that we have it equilibrated with the relative humidity of your surroundings. So usually in the morning, our relative humidity is much higher than it would be midday. And normally we would be using this to measure plant water status at midday. And same with the pressure chamber. So we want to, does anybody know why we'd want to do midday measurements?
It's the most active.
Potentially the most active.
Because your stomas might not be open midday if you're under water stress.
Exactly, yeah. So if you're going to try to capture water stress, it may be that time of the day, but that could be a logic. It could even be later in the day that you'd have that shift. But one of the reasons is that's when your conditions are the most uniform to get some of the measures done. So this day actually is a perfect day for water stress monitoring, because the key thing is you have to do it on a clear, cloudless days, because you wouldn't believe how much a shift in light will change, especially stomatal conductance. When you're measuring a smaller unit, it's more impacted by whatever environmental conditions you have. Probably less affecting this, if I would say, the amount of variability that would occur on a cloudy day or even a day that's sunny but has some clouds. Probably going to be more variability with this than with this. But what we do as a research standard is that we always do these measurements only on clear sunny days like this. So it really depends on the year. Some years we usually go out and take weekly measures with our pressure bomb, but some years, like 2011, we only had 9 sample dates because there were only 9 weeks where it fell on, of course, working with spray schedules and everything else, where we could get into the vineyard from June through September and get a good pressure bomb measurement. And the same would be for the leaf pyrometer. And just recognize if you are getting these measurements on a not perfect day, because I recognize you're not all researchers, that you just may get more variability on a day where you have a cloudy skies. And certainly on days that are overcast, it's going to read very different than on days that are full sun. So typically protocol is clear, cloudless days, and typically during that solar noon time point. So it can be an hour before or an hour after solar noon is when we'd want to do these measurements. Let's see if there's anything else that I wanted to showcase. Do you guys want to have any questions about these before we actually go in and try some of these?
You said you could actually go a little bit later.
Yes.
Which actually is actually better depending on your orientation. You just can't work that week after noon.
Yes,
And
that's
two,
correct.
It's like, oh, there's a lot of them.
We don't actually like midday, perfect midday, because it's very hard to find a well-exposed leaf. So that reminds me too, one of the things you need for this is fully, clear, cloudless days like this, but also leaves that are fully exposed to sun. And that can be somewhat difficult. You think, oh no, these vines, it's pretty easy to see, but it's actually sometimes difficult to find a positioned, perfectly exposed leaf that you want to sample for this. And it is true that we have a small data set, not a lot, that shows that if you can take the measurements actually on the back half of solar noon and get very little variability than if you did it on the front end of solar noon. So that was Paul Schreiner. He did some of that work and found that he could almost go up to 4 o'clock in the afternoon and be okay. And what he did was he plotted where the flat line was, and basically from about 11:30 till 4 you were okay. So you have a bigger window. And I think for those of you who want to get measurements, it's nice to know that you have a more wiggle room, because it's hard to get through a lot of vineyards in only a 2-hour period. So, yep.
Have you run the pressure column parameter on the same plant at the same time?
Yes.
And how much variability?
So it's hard to describe because this will give you a totally different number. So this doesn't measure pressure, it's measuring water flow, so our water vapor flow. So it's going to have a range from 0 to 300-400. And this will read in pressure. So, but how do they align? They do align. So if you've got a plant that's under water stress, that's maybe 12 bars, this is going to read probably 150. So there is an alignment there. I've done more testing of this with my gas exchange unit than I have with this with the pressure chamber. What we've noticed in doing this, and I didn't bring all of that information today. I could have brought a lot of figures, but if anybody's interested in that after this, please feel free to contact me. I've got some figures I can show you. What we found is late season, it seemed like this got a little harder to use. If we're doing it mid-season, July, maybe early part of August, it seemed to align very well with the pressure chamber. So aligning meaning that if this is saying it's under stress or vice versa. The tricky thing was most of the time we did this, we were never under water stress. So, it would be nice to be in a vineyard where we do see more water stress so we could test it. But we saw more variability between the two when it got into September. So when we were getting late season, and especially if it was very hot out. So if it was a very hot day that we were doing these measurements, it was much harder to get this to agree. And part of that is probably to do with a shift in relative humidity. And just because you calibrate it for an area, then you move to a canopy and you've got actively transpiring vines, and then you get this huge amount of change in your relative humidity, and then you're starting over. So it just takes a longer time for this to get back to normal, because you're trapping a leaf in here, then it's measuring that water vapor flow out of it, and then the little tiny chamber in there gets really humid, and then you have to wait till it clears out, essentially, and is able to dry out again to the next leaf. Whereas this is measuring something different, and so you just get a little bit more variability. Depends on the time of year, but it still works. And I think the biggest issue is making sure that the calibration step is done on this. There is no calibration step for the pressure chamber. Of course, you may get some differences with this, but it's probably more likely to be due to the vine itself, just the shift in the water stress itself within a vine and your sampling.
You want to try to use the same area and same age of leaf for both?
Yeah. Yep. So the sampling can be exactly the same. One of the things is never use lateral leaves. Try to use main or primary leaves, and always fully mature leaves. So usually we're not looking at the basal part of the canopy on a VSP. We're looking at the mid to upper. And certainly, again, time of year. So if you take really early measurements around the bloom time, you're going to have really young leaves at the top. You wouldn't want to use the youngest leaves, because young leaves will act slightly differently, and same with laterals, will act differently than a main shoot leaf. So, yeah. And so to make things a little bit more, not complicated, but a little different, and I'll show you this in the vineyard here, is with the pressure chamber, there's two types of readings you can do. There is leaf and stem. They both involve a leaf, but one measures a leaf that's been covered with a plastic bag, this type of plastic bag, where it's a mylar bag that basically, I buy these directly from the same company, so I've used these for 6 years, so they last a long time. You put these over the leaves for at least 2 hours, or at least an hour. We like to do 2 hours before our readings, and what this does is it actually makes the leaf equilibrate to about the same water status as the rest of the vine, because it's no longer exposed to the sun, and it's now in a moist chamber essentially. And so that's why you have to leave it on for a while. So that we cut the leaf off and we take our measurement, and that's considered stem water potential. So that number can be slightly different than a leaf water potential where you're just going up to the vine, finding a well-exposed leaf, pulling it off, and taking your measurement. So usually the difference there is about 1 to 2 bars. So you might get a reading from this one that's only 10, whereas the leaf one might read 11 or 12. And so then the caution there is if you only take stem water potential, that you would have to shift your water status a little bit for when you'd make an irrigation decision. So, but in different trials, it's been actually on average of about 1.2 bar difference between a stem versus a leaf water potential reading. So, you want to go into the vineyard and give this a try, see how it works?
Is your professional one, does it have the same problem with the calibration, or is
So
it quicker?
Um,
Or the whatever it's called?
The professional one takes 45 minutes
Oh,
to set up. And it's a 3-page like how-to, and you've got to have it just right. So it's because of what it's measuring. You always have to have it equilibrated. In that case, we have to have it equilibrated based on relative humidity, sunlight, and temperature. So it takes a longer time. This, I think, if it was midday, probably would take less time. And in the manual, they say about 10 minutes is what it takes to calibrate this. So I'm going to just show you how, assuming I just went through the calibration and we're good to go, the sensor has got the bottom half is where it's actually reading the flow. This metal part here, it's a clamp, and you clamp it onto a leaf, and there's a desiccant that will go in the bottom, so it's helping to control the relative humidity. So I'm going to put it on a leaf here. This would be, you normally don't measure end vines, but for illustration purposes, I'll just show you. You don't want to use damaged leaves either, so this is a good example. I would never choose this one here. I would use a nice well-exposed leaf here in the upper portion of the canopy. And what you do is you clamp it onto a leaf here, and it's best to have the leaf still exposed, even though when you're putting the sensor on it, you're not making a. So I have to do a quick equilibration. So this is what happens between measurements. You have to sit there and do this because it's mixing the air inside that little chamber, and it's telling me that the initial conductance is too high, that it's got to equilibrate first. So you have to do, this is usually what you have to do between readings as well. And this doesn't usually take very long. It's just something you have to do. And the nice thing is it's foolproof for that, but you can take measurements without calibrating it. And that's what I found from some people who have used it, is they'll start taking they said, I've never calibrated it. Well, that can be an issue. So if you want to come and see, it'll also already be giving me readings. So you can come on and look. And what it's giving is that top number there under the word measurement. You see that? It's changing. So it's going up, up, up. So it started out at about 160. Now it's up to 340. It's jumping fast. That's the millimoles of water per meter squared per second. So that's how much water vapor is moving through. At this, we're up to 466, and it's kind of stopped there. And that's pretty high. That leaf has no issue whatsoever. And if you look on your page, I think that I have listed there anything under 250 is maybe mild stress. And then so we're, double what would be considered mild stress. So if we went to, here's a leaf that's right at the tip. It's kind of positioned away. I'm just going to do it for fun here. It would not be one I normally take. Got to remember, between each reading, you have to sit there and do this. It doesn't mean that it's a bad device. It just means you have to, this is, it's not instantaneous. You can't run and get 500 measurements in 5 minutes. You've got your measurement, which went pretty quickly, probably 30 seconds it took to take the measurement. But you've got to clean the sensor. Essentially, just get the relative humidity back down.
would you take a certain number of leaves, or on the leaves a certain number of different positions on the leaf?
So I would say you can take multiple positions on the same leaf, but rather than that, I think the better thing to do would be to take multiple leaves per vine.
Because you would think you would get the 460, whatever. on different areas of that same leaf.
Possibly. I mean, we can try it again to see. You would likely get about the same. So we can try it. This is a different area on the leaf, and you should get the same. You know, if the whole leaf is acting the same, it should be a relatively same measurement. And that's why, yeah, you'll probably get slightly different ones, in part because of your timing too. It's really hard to get perfect measurements because you have shift in time in your, different stomata. They're not going to stay static at one. They're going to be in a certain range. Like this is saying 500 now, 515, 534, 546 is where it stopped. So I think the bigger thing is taking a number of leaves for a reference vine that you have rather than worrying about getting multiple positions on a leaf, and just being as strategic as possible about getting the measurement. Can you just take one measurement per block and move to the next block? Probably not. That's where what we were normally doing for pressure chamber, and when we compared this to the pressure chamber, we were usually doing three leaves per plot, which our plots were 8 vines. We would do 3 leaves, which usually was 1 leaf per 3 vines, and we would measure them first with this and then with the pressure chamber. So we'd always do this first because with pressure chamber you have to remove the leaf. So let's see if we can get maybe a shaded, I'll do a shaded leaf down here just to show you what a difference might be. Oh, that's right. So it never lets you take another reading. It actually tells you if conductance is too high, you gotta clear the sensor before taking another reading. Actually, if somebody else wants to give it a try, you're welcome to. You can just clamp it on a leaf and watch what happens. Anybody?
I'll try.
Just wait till it gets. All right, so now we're ready to go. Sure, yeah, if it's facing away, and just make sure the metal part is on the underside of the leaf. And then one of the things you have to do is always make sure that it's facing down. Yep, so you'll have to do that. Let's see what it reads at. And then it gives you some other readings there that are, it's relative humidity of the chamber as well as the temperature of that leaf. So you can see the leaf is pretty hot. It's at 30 degrees C. So this one was 440. So about the same, but a little bit less than the other one. So, and you can automatically save your data on here, so you don't need to have somebody standing there with a note, pad or taking notes yourself. You can just auto record and annotate data. It's not the easiest to annotate because you have to have, up and down. It's not like, smartphones and everything. But that's how this works. So pretty simple. It's just remembering that it probably takes a couple minutes to calibrate or equilibrate between readings, and the critical thing is you can move pretty quickly and get lots of measurements, but you still have to get a lot of measurements. So the other one I want to show you is the pressure chamber. So I would like you guys to come a little bit closer and take a look at So first of all, thanks for this. What I did was, first things we did when we got here this morning, we put out some of those Mylar bags. So these bags, so we can actually do a stem water potential and a leaf water potential. So each of these 3 rows has some. You can probably look down the row and you can see a leaf that we selected. And at the time that we selected it, we wanted to have leaves that were fully exposed to the sun. We put it on the petiole or on the leaf. And some of the leaves are pretty big, but you can crunch them in there, don't break them, but obviously you can still bend them. And we just tighten this right around the petioles, and they seal very nicely. So we have those there. The hardest thing in doing that in commercial practice is how do you find these once you've put them out? And you just have to have that added step of getting out and putting these out in the vineyard. For our small research plots, we are in a confined 1 acre block, and we can easily put these on vines. We know where they're going to be. It's pretty simple. But one of the best things that we could think of is that some people who might do this commercially would put some flagging tape on the ends of these, so you could at least see a brightly colored flagging tape. And you can buy this at, many of you probably have some of this in your toolboxes anyway, but this is probably the best bet, is just to tape them to the end of these so you can find them later if you're going to do them. I definitely prefer stem water potential for research just because there's less variability. But in reality, it's probably not all that practical for a commercial setting. So what we'll do is I'll show you first the leaf water potential, where we just select the appropriate leaf, do the pressure chamber reading on that, and then we'll do one for comparison on the same vine. So I stopped a little late because I hear some gas. Yep. And when you hear that, then there's something not quite tight enough, probably not this. So I got to about 12 bars right there. It's probably not 12 bars. It probably was because I could hear hissing. So I'm going to exhaust it and we can just start over. But when you take this measurement, people get a little nervous because they're like, oh no, I've got to watch and actually this is just an on-off switch. When you're hit, you don't have to worry this won't fall back down. You catch it, it'll stop wherever you stop it. So the critical thing is listening for that gas because it was probably escaping here. And then if we took another reading, it probably will be a little different. So let's get it. We'll get a similar leaf, same vine, different leaf. Again, you can see how slow it's going up. And once I actually get it bubbling, I'll show you guys. And earlier this morning when we did a couple, we were at about 9 bars, which surprised me, even for that early in the morning.
Surprised you on the high side or the low side?
High. Normally we would get lower measures. But it's also getting later in the season. So they may be under more water stress than I thought. Oh, yeah. So there we're at 11.5 bars. If you want to look, you can actually see the bubbling. It should be still kind of fizzling. You can actually see it with your eyes, or you can look in the magnifying loupe. So yeah, this time of the year, this is when we would start to first see any water stress that we might have. Now we're going to do the stem. If you get
Hey Patty, we're rotating now, so
okay.
we can wrap it up in a minute or two.
So I'll take the stem water potential and we'll see what that's at.
Just a quick question, Patty. On your interpreting the data column, you've got the water stress levels in bars. Is that for stem water potential or leaf water potential?
Do I have both? Or
No, just one.
That's in leaf.
Leaf.
Yeah.
Cool.
So I was going to add both, but yeah, that's in leaf water potential.
Okay. And what would you recommend for stem?
You'd subtract about 1.5.
1.5, okay.
1.5 to 2. Yeah. I usually would say 2 to be on the safe side. So for the stem water potential, no need to do the other plastic bag because this was just in a plastic bag for a long time. And usually you take it off and it's pretty moist because it was just trapped in that bag. And this should be under less stress. So it'll probably be a lower number. But we'll see how much lower. And if you have it set too quickly, the chance of you overshooting the target is pretty likely. So that's why we've got it set pretty slow. We actually increase it a bit for highly trained people who've done it a lot. So this one is 10.5, so a bar less than the other leaf. But yeah, first maybe.
So would you say that this block needs irrigation? Or it's not at midday, so you don't.
I would say, yeah, it would be hard to tell at midday, but you would think that if it's at this level now, midday it might get.
Yeah. I mean, there's extremely good cane lignification
Yeah.
here.
Yeah,
Say
and
that
there's
it's-
certain spots within this block that has more stress than others.
Yeah.
Especially if you step back and look that way.
Yeah.
There, you can see the canopies are smaller, a
Yeah.
little bit lighter green. So, we did last year get to stress.
Yeah.
For the first year, like getting to
Yeah.
10s on, and we've done leaf stem and parameter
Yeah.
in this block last year. It was
Last
great.
year, I mean, last year was a great year for
Yeah,
that.
it was
a
perfect.
drought year. So.
We're down in the Missoula flood soils, right? We're
These
not
are-
in the Jory anymore here, I
Yeah.
don't think.
Well, no, we're Jory still. At least maybe not in this exact spot, but definitely in our research plot area. We're in the Jory soils. Yeah. So that's that.
Cool. Thanks, Patty.
You're welcome.